Math 3, Unit 4, Section 4, Part B. So we're going to continue. We're trying to solve for x, and then we also need to make sure we always check for extraneous solutions. And who remembers what extraneous solutions mean? What is extraneous solutions? Why do we need to check for them? They can't be the solution is correct, but specifically, they will end up making a 0 in the denominator, and a 0 in the denominator is undefined. Undefined or not good. Okay, good. So, we're going to factor each of our denominators to check to see what our LCD would be. Here, if we're factoring, okay, my multiplication number is 12, and my adding number is? Very good. Okay, what numbers will work? Negative 6. That's, I knew what you meant. Okay, negative 6 and negative 2 is correct. So this right here is going to factor to be x minus 6, x minus 2. The next one, the x minus 2, is I'm going to put parentheses around it because it's connected with that subtraction sign. And this last one, can I factor or do anything to it? Very good. We can factor out a 2. And when I do that, I'm left with x minus 6. Okay, so based on all this information here, we need to figure out what is our LCD. Okay, so up here to the right, I'm going to go ahead and write LCD is going to be what? So you kind of look through it, each of my denominators. Okay, I like to put my monomial, that single term at the front, and so I know for sure because I have a 2 in one of my denominators, I'm going to need a 2. Okay, bless you. And then as we go through here, see how this one has an x minus 6 and an x minus 2? That means I need an x minus 6 and an x minus 2. And then you kind of go through each of the denominators. This has an x minus 2, but I already have it, so I'm good. This has a 2, I already wrote it. And this has an x minus 6, and I already have it. So that would be my LCD. You just need to make sure everything will end up being able to be canceled with this. Okay, so based on this information, what are my extraneous solutions?
6 and 2.
Very good. 6 and 2 is correct. Because the 2 at the front, if you set that equal to 0, that doesn't even make any sense. 2 cannot equal 0, so that's not a solution. And then we set each of our factors equal to 0, which gives us a 6 and a 2. Who remembers what I do next? Multiply LCD to every single term. So in this problem, there are 1, 2, 3 terms. So I'm going to go through and write 2 times x minus 6 times x minus 2 next to every single term. Okay, and then next, I'm going to go ahead so that I don't mess up. I'm canceling out that bottom because it matches this. These mean the same thing, right? Just written different ways, so I don't get confused by those being there. And we're going to go reduce. So on the first fraction here, my first term, what happens? X minus 6's cancel, and x minus 2's cancel, and what am I left with there? A 2 and a 4, and you can multiply those together if you want to, and that makes an 8. Okay, next we have an equal sign. On this next term, what happens? Very good. And here I'm left with an x, a 2, and an x minus 6. So you can multiply all that out if you want to. I'm just going to write it right now and we'll distribute it later. So I'm going to write this as 2x times x minus 6. All right, and then we have a plus sign. And my next fraction, what can I do? Okay, this 2 can either cancel with this one or this one. It can't cancel with both. So wherever you reduce it, that's fine. And then what else can I reduce? X minus 6. And so I'm left with x and x minus 2. Or did I say x? I meant 2 times x minus 2. I don't know what's going on. 2 times x minus 2. Are we all okay with that? All right. Now what? Yeah, we need to solve for x, and so we want to get rid of all of those parentheses, so we're going to distribute. Okay. If you guys have questions, please ask me some of the side conversations. I'm not sure what's going on. So, yes, Genesis.
Okay, so for the top, you like multiplied it by the denominator, right? For the LCD?
Yeah, so we take the LCD and we multiply it to every single fraction, and the purpose is to eliminate the fractions. Okay, go.
That's how it canceled out the bottom.
Yes. Okay. All right. All right, so now we're distributing. 2x times x is 2x squared. 2x times negative 6 is. Okay, and then right here we have a positive 2 times x, which is 2x, and 2 times negative 2 is very good. Okay, we know that when we're solving for x, we end up wanting it to be set equal to what? 0. So what I'm going to go ahead and do is subtract 8 over here right now, and then I'm going to go through and combine all my like terms and get it into descending order. Okay, so 2x squared, there's nothing to add it with, so I have 2x squared. And then we have a negative 12x, and I forgot the plus sign there. Plus 2x will make what? Very good. And then negative 4 and negative 8 makes negative 12 equals 0. What would I do next in order to factor this? So you always check for GCF first. So that's going to make things a lot easier, and so we can factor out 2. And we have x squared minus 5x minus 6 equals 0. Next, after that, then we'll do our trinomial factoring, where we check for our multiplication number and our adding number. So my multiplying number is negative 6. My adding number is negative 5. What numbers will work?
1 and negative.
Very good. 1 and negative 6. Always double check that these actually do work. They do multiply to be negative 6. They do add to be negative 5. So that means we can we use our shortcut on this one? Yes, and so because this is an x squared, we split that up and we get the x in front of each of the parentheses. And then I have a plus 1 and a minus 6. When I solve that, what do I get for my answers? Will 2 work? No. X plus 1 will make a, and x minus 6 will make a. Do any of these match with my extraneous solutions?
6.
So we cross 6 out. That will not work. And then my only answer is x equals negative 1, which means I have one solution.
Wait, so if you have a matching
Yes.
number with the...
What that means is that the answer of 6 would actually make a 0 in the denominator of the problem, and a 0 in the denominator will make the problem undefined. And so it doesn't actually work. So you always have to check extraneous solutions.
Doesn't the first one match?
What, you mean negative 1?
Yeah.
No, there's only 6 and 2 for extraneous solutions. Okay?
Wait, when did you get those?
You get your extraneous solutions by setting your LCD, your common denominator, to 0. So 2 equals 0 didn't give us anything. X minus 6 equals 0 gives us a 6, and x minus 2 equals 0 gives us a 2. All right? So extraneous solutions come from your LCD. The LCD is coming from your denominators. We're basically figuring out what the common denominator is, and we're multiplying everything by that to eliminate them. So this would end up giving me zeros in one of my denominators. Okay, anything else there? All right, let's do another one. Okay, so on this one, we have this f of x piece, which just means that wherever we see f of x, we're going to end up plugging in x plus 2. Can we do it?
Yes.
All right. So, on the first fraction, what am I going to write? x plus 2 minus 2 over x plus 2 equals 3 minus 2 over. Very good. Now, what will be my LCD for this problem? Good, x plus 2. And I'm going to go ahead and put those in parentheses so I remember that they're stuck together like glue. So my LCD is x plus 2. Extraneous solutions. All I have to do to find my extraneous solutions is set my LCD equal to 0. So when I do that, I end up getting? Very good. So x cannot equal negative 2. If that ends up being a solution, it's not really a solution, and we cancel it out. Okay, so next step is to do what? Perfect. Multiply every single term by the LCD. How many terms are in this problem? 3. 1, 2, 3. Okay, so we multiply every term by x plus 2. And then we are going to simplify. Okay. X plus 2's cancel out. Sorry. So we get, there's x and then plus 2 and minus 2, which makes what?
0.
Good. Those do make 0. And so we're left with just x on that one. Equals. Can anything cancel out on this one? No. So I'm just going to write that as 3 times x plus 2. Minus, and then on the last term, what happens? X plus 2's cancel out, and we're just left with 2. Okay, and so now we're going to solve. We do that by doing what first? Good, we can do both at the same time. We also need to distribute. I'm going to go ahead and leave the x here for just 1 minute. 3 times x is 3x. 3 times 2 is 6. And then I still have my minus 2. What? Yes.
How did you get the x?
Oh, so right here, and you could have rewritten it as x plus 2 minus 2, but I knew that the 2 and the negative 2 would make a 0. And so we were just left with x there. So this was what was left in the next one, and this what was left in the last one. Do you agree that 2 minus 2 is 0? Okay. All right, so then I'm going to do, okay, so do you see how we have no x squared terms? We just have x terms. So this is where we can just solve for x if we want to. You don't have to have it set equal to 0 at first. If you want to, you can. But what I mean is that normally at this point, we would end up getting all the x's together. And so I'd have negative 2x equals, and 6 minus 2 is 4. And then you would divide by negative 2 to both sides. And so x equals negative 2. Does that match an extraneous solution?
Yes.
Yes. So this is not an answer. Which means what? No solution. Are we okay with me not setting this equal to 0 and just solving for x?
Yes.
But anytime you have an x squared term, it has to be set equal to 0 because then you have to factor. Okay. All right. Any questions here? All right. Let's go ahead and go to the next page here. And I'm not going to solve both of these, but I want us to set them up. So here it says given f of x equals 2 over x plus 2, and g of x equals x minus 7 over x squared minus 4. Solve the equation f of x equals g of x. How would I solve this? What would I do? Do we all see how this is f of x? So that means I would put that right there, correct? And do we all see how this is g of x? So we would put that right there. So if I write this equation, it would be perfect. Okay, what would be your next step on this problem? LCD. Good. Okay, now in order to find the LCD, you want to factor any denominators. Well, can either of those be factored? Very good. Yes, is the correct answer. Because x squared minus 4 is, very good, x plus 2, x minus 2. And then I'm going to cancel that out there. So LCD, we know we need an x plus 2. Okay, when I go here, do you see how I already have an x plus 2? And so, but I still need an x minus 2. What would be my extraneous solutions for this problem? X cannot equal 2, and it cannot equal negative 2. Okay, so to finish this problem, what would I do? Multiply by, very good, x plus 2, x minus 2 to every term. How many terms are on this one? Just 2. Okay, when I do that, on the first one, the x plus 2's cancel out, and I'm left with, very good. I'm going to write this right now as 2 times x minus 2, but you can skip that step if you want to. And then the next one, what happens? Yeah, the x plus 2's cancel out and the x minus 2's cancel out, and I am left with, very good. Okay, what do I do now? Distribute the 2. 2 times x is 2x. 2 times negative 2 is equals x minus 7. Do I need to set this equal to 0? Nope, because there's no x squared. And so I would just try to get all my x's together. So I'm going to subtract x. At the same time, I'm going to go ahead and add 4. So I have my numbers on one side, my letters on the other. 2x minus x is? Negative 7 plus 4 is? Does this match an extraneous solution? No. And so my answer is just x equals negative 3. And it is one solution. Very good. Okay. Last one, and this one I'm not going to solve all the way, but I just want to make sure we understand how to set it up. This says f minus g of x. How will I set that up? How am I going to set this? Oh, sorry. F minus g of x equals 0. Very good. 8 over x squared minus 5x minus 6. And then? Perfect. Perfect. How many terms are in this problem?
2.
There's actually 3. So this is 1, 2, 3. Okay? Now, what would be your first step on this problem? Yeah, we want to find the LCD, so we'd end up factoring each of these denominators. Okay? What can this one factor to be?
1 and negative 1 and negative 6.
Very good. 1 and negative 6. So I'm going to rewrite this as x plus 1, x minus 6. Can this one factor? Take out an x and you're left with?
X plus 1.
Okay, so what is my LCD?
X plus 1. Or x.
Right, so we need that x plus 1, and
X minus 6.
x minus 6. So if you look, the first term, you have your x plus 1, and we have our x minus 6. The next one, I still need an x, and our monomials, our single terms, always go in front. So that's why that x is there. And then I need an x plus 1, but I already have an x plus 1, so that makes my LCD. So you kind of just go through and check each term and keep adding anything that's missing. What are your extraneous solutions for this one? 0, negative 1, and 6. Because x equals 0, that does make a solution. So remember, you're setting each of the factors equal to 0 to find the extraneous solutions. What would be your next step now? Multiply every term by x plus 1, x minus 6. So we're going to do this last part, and then we're going to stop on this problem. So I'm writing x times x plus 1, x minus 6 to every single term. But one thing to notice is that when I go 0 times anything, it makes what? 0. So this side is still going to be 0. Because 0 times all that will make 0. On my first term, what happens? Good. The x plus 1s cancel and the x minus 6 cancels. And so all we're left with is our 8x. Very good. Okay, and then I have minus. And on this one, what happens? X and the x plus 1s cancel. And so I have 2 times x minus 6. All right, and then you would distribute and solve, and you could finish that later, but it's not too bad. Any questions? Okay.